page, I added a link to it as well. So the main LSR working group page has a separate link to the status. The highlights, at least you all might think this is a rather parochial view of the highlights, but I think it's because I've worked on, in some capacity, I've worked or been the document shepherd for these documents. I think one thing is we've had the Yang models, we're going to go forward with them. Both were pretty close on OSPF, actually. I realized we needed one more IPR call, and I'm just rounding up all the contributors. The authors are all ready. We've been doing the design meetings, and ISIS is coming shortly. We got some Yang doctor comments, and we had a mission on them. Stefan's working on those. The MPLS data plane SR documents are pretty much all working group last called, and or waiting on Alvaro. So those are multi-year documents that, as shepherd up to them, I'm glad to see those go by. The other documents that I think are really interesting, we have presentations, so I'm not going to waste any time on those. Let's see. And I know we have a lot of different flooding proposals. We may have an interim on this. I don't really think it's a good idea to try and do it at the end of the routing working group, because who knows, exactly when it is, and we'll probably lose people. So we might have an interim to talk about the drafts that have a lot of overlap. And that's it. Okay, should we go with the first presentation? You want to say, yeah, you want to say something?
Yeah, Les asked to get some push forward on a couple of things. He's like, what's going on with this? Mention it. So the TE this draft is submitted. Is Uma here? I think is he the holdup on the segment routing extensions?
No.
No. What is the holdup on that?
8 authors. I told them to get down to 5.
Yeah, okay,
It's me. I'm the whole.
Never mind. It's just we just need to narrow the author list.
Yeah, but I mean, so
It's
have you done the ISG submission, or do we have to resolve the author issue first?
let's see, resolve first, right?
I mean, it should be. It'll go to Alvaro, and he'll probably have the same comment.
So
Yeah. I mean, we'll take care of that.
do first.
I'm just saying, it might take us a few days to, see who gets the short straw or whatever. So
That's the only thing holding it
Yeah.
up.
Okay. So the first one is less, I think, right?
Is it in order on this?
Yeah, they're in order.
Yep.
You got a few of them. Oh, one thing in my hurry. You all know about the note well, that if you know about any IPR, you're obligated to disclose it as early as possible.
Seems to work.
And I'm sure if you've attended any other working group meetings.
Oh, we didn't do it.
We didn't do the note well. Yeah.
One second. It's right here.
So you want to show it now?
Here's the routing. Here's the routing working. It's the same thing. So note well. Noted. Sorry about that, Les.
Okay, I'm Les Ginsberg. This is a joint presentation on the two TE attribute drafts, one for ISIS, one for OSPF. These are changes since IETF 101. We added the TE metric. Somehow we had overlooked that. We added that as a sub-TLV that was supported in the per application encoding. We also allowed that the per application TLV or sub-TLV could be associated with the L2 link bundle TLV in ISIS. And we moved the registry that's defining the application bit identifiers because it's being shared by ISIS and OSPF. We moved it to the IGP parameters registry. And OSPF v3 support was added. This was actually presented in Montreal, but just included it in the list. We feel these drafts are mature. There's been a lot of discussion about this. These have been 3 years in the evolution. There are some implementations, so we feel like both drafts are ready for last call. I will mention there's one minor editorial change to the OSPF draft that's coming, which is just to make sure that the length of the application bit identifiers is a multiple of 4 bytes, which is consistent with the way OSPF does encoding. But other than that, we'd like to see these go to last call.
Does anybody have any objections to this call? We'll make on the list. I guess I'm a co-author of one of these drafts, but although they're not, I don't think we have any implementations that are released, but at least there's been a test of people actually coding to it and testing with it already with these encodings. So I'm glad I did that before Chris entered the room. I see he's in the back. Okay, so we'll take it to the list. The working group last call.
Just keep going. Oh, it just keeps feeding?
Yeah.
Do you need a new presentation?
Yeah.
You seem to be more dexterous
I don't know.
than me on this.
Oh. No.
Just I jinxed you.
Yeah, you did. Why doesn't it do square though? Maybe this.
I had so much trouble with that last
Oh,
night.
there we go.
Okay. This is an update on the restart signaling BIS draft for ISIS. Here's the history. We first introduced this in March and presented it in London. There was an update. The update was basically to include an appendix that had the summary of the changes from RFC 5306, and we presented that in Montreal. This was adopted as a working group document in October. Really, in the 8 months here since we first presented this, there really hasn't been any significant comments other than to summarize the changes. This is really a modest extension to the existing restart protocol for restart functionality for ISIS. And in the absence of any concerns that have been expressed, we'd like to move forward to last call. I should also mention this functionality is equivalent to what's been in OSPF for many, many years.
Okay, is there any objection in the room to taking this to working group last call? Does anybody think this is not ready for that? Who's taking our minutes? Oh, yeah, never mind. Okay, nobody thinks that. Nobody objects.
Next. The rest of those slides are just for backup. Okay, this is an update on the spine leaf extensions for ISIS. We've presented this multiple times in the past, so I'm not going to spend a lot of time going through the details. Just a quick overview. This is a fairly modest extension to ISIS. We believe it addresses a number of issues in the data center topologies. It particularly addresses the flooding problem to the leaf nodes. In most cases, there's no flooding done to the leaf nodes, but we do have extensions to allow us to recover when there's incomplete connectivity between some of the spine nodes and the leaf nodes, so that we don't black hole traffic. That we can advertise essentially the routes that are need to be exceptions from the default route that you would otherwise use from the leaf nodes. So if there are link failures, we do address that and avoid the black hole. We are compatible with a number of other extensions. The dynamic flooding extensions can be used in conjunction with the extensions defined here. There also are some mechanisms that we introduced in support of Russ White's open fabric draft, particularly some of the auto provisioning portions. We made a few modest changes since the last IETF based on comments we had received, largely from Tony P. Thanks very much to him. We had support for the horizontal links between the leaf nodes, and we had a flag that would indicate that the leaf node could be used as an alternate default route. The feedback that we got was this was adding unnecessary complexity, so we have removed that, and essentially we're just not making use of the horizontal links between leaf nodes if they exist. We also clarified that in these cases where some of the spine nodes don't have full connectivity to the leaf nodes, that you might have multiple link down events, and therefore you might have to exchange some of the protocol extensions to multiple spine nodes, not just between one leaf node and one spine node. This is not a change, it's just a clarification. And we also added text that suggested that although the extensions we defined are intended to be really primarily targeted for the tier 0 between the leaf nodes and the next layer of spine nodes, that in theory you could use these extensions for additional layers. So again, this draft has been presented. I think this is going to be at least the 4th time. I didn't go back and count exactly, but I know we've presented it multiple times. We have made changes based on the comments we've received. And so we're back here, not for the first time, but we'd like to ask for working group adoption.
So I guess I have a few comments. The dynamic, the dense flooding compatibility with Tony Lee's and et al. Is that just using the advertisement of the distributed algorithm? The fact that it's using this algorithm?
Well, no. So with the spine leaf extensions, essentially the leaf nodes, the LSPs from the leaf nodes are not part of the flooding. So so they're just not part. So you use the dynamic flooding extensions for the upper tiers, and you use the spine leaf extensions basically to almost completely eliminate the flooding to the leaves.
So I mean, sort of, it's kind of like overloaded LSP operation for the leaves, I guess. But anyway, right? They're advertising their own LSP with no flooding to them. No, so when you said the horizontal, I just reread the draft. I don't remember that being talked about. Obviously, you said it was removed. Do you talk about not flooding over those horizontal links between leaves?
No. So the previous versions of the draft, we allowed that there was a B bit that essentially a leaf node could say, I'm potentially a backup path for the default route. Instead of going to the spine, if your spine is compromised, your spine neighbor is compromised, you could come to me. The feedback that we got was this is just an unnecessary complexity.
You don't mean compromising failure.
Okay.
But so you still, when a leaf comes up, it floods to all its links, the horizontal and to the spine.
So the leaf nodes are nominally going to flood to their spine neighbors. Okay, the idea that that the leaf nodes do not have to have the full LSP database. They just need to know, hey, what spines can I use for the default route? And if there are some compromised connectivity, then they need to get some advertisements from the spine nodes to say, well, for this set of prefixes, you can't use me.
No, I understand that. I'm saying I didn't see anything in the draft that talked about the horizontal links. You're saying they can be there, but what happens when they are? Does it flood? Do the leaves flood? Do the leaves flood their? I know they're only doing their own LSP, right? And they're not going to hold on to any other. But are they flooding their own LSPs to their leaf neighbors in that case? Or I guess I'm just asking for that to be covered, right? Because it's not going to do the R. It's not going to do the RL exchange. It'll be like LL, right?
Correct.
And what happens in that? That's all I'm saying is I didn't see that was.
Naming, do you remember? I'm drawing a blank.
Yeah, I
State
think
your naming.
naming Shen with Cisco systems. Yeah, I think before we were saying we have a B-bit if we can go through this to reach the other one. Now, if we really in this particular case, I think from flooding point of view, from leaf to leaf, we don't do anything special. They just flood it over. But we don't flood our neighbor's LSP back over there.
Right.
Yeah.
Maybe you could add a section on the relationship to horizontal links.
Right. I think we probably need to put some statement saying we need to put high metric between those two or something like that. Right.
Yeah, I mean, it's not particularly useful because we don't have the topology connectivity.
Right.
Yeah.
I just had one comment as a working group member, speaking as working group member, AC Lindum of Cisco Systems. I think this has little overlap with the other proposals. So I think, and it's a very modest proposal. If there's any overlap in functionality, it's an overlap. It does a small subset of what Rift does. So I don't think it has overlap with the remainder of. So I think we could safely working group adopt. Shouldn't call this one without worrying about overlap. Other opinions?
Well,
You don't agree?
I haven't decided yet on whether I think we're close. I don't think that the work is. I mean, other than what I just mentioned, right? I think the work is kind of done, right? I don't think that it's just a question of do we push it forward right as we're about to sort of collapse. Well, I think we're going to be collapsing a bunch of other flooding stuff. Do we do this one kind of ships in the night with those, or do we? No, I don't want to stall the work either because, like I said, it's done.
It can be done in the edge, and then you prune that.
Yeah, this is definitely a complementary proposal.
Yeah,
to the flooding reduction proposals.
It just handles that bottom tier, right? I mean, it's not. Yeah. Okay.
Yeah, I mean, we've allowed for the fact you could use this on the upper tiers, but that's not our primary target.
Tony P, Troublemakers Incorporated. I think a key discussion on this draft, so like independent of all the other stuff, will it go to the, 7356, or will it keep the stuff on the Hellos? And frankly, I think we should push for the 7356, because then it has potential. Then you can grow lots of other stuff.
Yeah, I think that
For the uninitiated, 7366 is a Linux scoped LSPs.
yeah. So right now the draft allows you could put this in hellos or you could put this in the link scoped LSPs.
And what
I
if you
think
do
clearly
both and they contradict you?
the link scoped LSPs are a better solution. So I have, personally, I'll consult with my co-authors, but
Okay. Yeah.
I have no objection.
Yeah. Okay. So that's comment from me, independent of the adoption and everything else.
So is this, I guess my question to you as the chairs is, because we've been here before, and basically the answer before was wait. So what's the answer now in terms of can we ask the working group for adoption?
Yeah, we can do that. I mean, I just have my own opinion. I'm not saying as a chair, I don't think we're ready to ask that. I really wish we could do that interim. If we're going to do an interim on the flooding stuff.
Yeah, and we disagree on this point. I think this doesn't have overlap. So the fewer things we're trying to coalesce in the interim, the better. And this just is, we can do this as an interim enhancement. The other thing that's interesting about this, we have implementations going. So I hate to delay it while we're waiting on all these drafts that are related to subset or separate flooding topologies from the total routing domain topology.
Well, like I said, I don't object as a chair, so
Okay.
we can ask the list. But does anyone else object in the room to this being working group last call?
No, adopted.
Working group adopted.
Hey,
Sorry.
let's go. Okay.
Tony P again. So if I would be running this group, I would probably, try to get into 7356 format. I mean, these hellos are an accident waiting to happen. And I think the flooding is not really a problem. It's an optimization.
You're not the chair anymore, but you're still a member, so you're objecting.
No,
I'm suggesting that it will be like,
So
good
Tony,
stepping stone.
I think that all you're suggesting, and
Yeah.
I support this, is we've got two mechanisms to
Yeah.
do these exchanges. You're suggesting get rid of the hello mechanism.
yeah, resolve it.
And-
Right.
I
And
think
the
that's
other
fine.
one, I think the flooding is an optional optimization. So if this is really the stumbling stone, you can just shelve it for the moment elegantly, right? The draft works nevertheless. It's an optimization, and then when things comes to fruition, you figure out what you do with that stuff. The
Yeah,
draft
I
doesn't
honestly
preclude
think-
you from reusing anything. I mean,
Yeah, I
just
don't think-
observations.
I don't think there's any changes that would be required to this draft with
No.
the flooding optimization.
Correct.
Flooding optimizations might have to take into account the signaling from this draft,
Correct.
not
yes.
the other way around.
But that is independent. I mean, whoever comes up with any solution, I mean, you have the signaling, and they, like you say, they have to properly deal with it, that the leaves cannot flood through, right?
Yeah. Right.
I mean, I'm not objecting, but I'm suggesting to ask for resolution of the mechanism. This is the time before the hex propagate. Okay?
Why don't you
Okay.
revive that? Maybe they might preemptively decide on that. But why don't you revive that when we call for adoption?
Sure. Yeah, I'll put it on the list, no problem.
Okay, that sounds reasonable.
Yeah, Naiming Sheng again. I agree with Les and Tony, and we can move to this link local signaling. But the original intention, I sort of insist to use the hello is, let's say we only have tier 0 and a tier 1. And above tier 1, there is a rich connections. For example, there's a ring among all the spines, right? So in this particular case, the only thing you need to do for this draft is signal, I do not want the flooding back. That's all. So for this simple purpose, if there's any link breakage or something, there is a possible to reroute in the upper layer. So in that kind of condition, I was thinking, you only need probably 100 lines of code to support this. So that's the idea. But yeah, if we are going to adoption or something, we certainly listen to whatever the group opinion.
Sarah, are you ready? You're done.
Yeah, that did, it caught me a little by surprise. I guess we'll take that to the list, of what the working group last call,
No, adoption.
adoption. Like, oh, boy. More coffee. Fast tracking
What is this? Is this?
this arrow. And then here, then you go back. This one, right?
It is. Yep. That's it.
Is that right?
Yep. This is it. This is the ball that covers both OSPF and ISIS now. No, that's not. That's
Yeah,
not,
that's why I
sorry,
didn't
sorry.
think that was right.
No,
Okay.
I must have put them in the wrong order.
We need
Sorry.
the dunce.
Yeah, it is. I think I missed it. That's
I can pull it up too.
you can?
I'm gonna try.
Okay. But, sorry,
This is when Michigan J Frog comes out.
I don't know how I got 17 proposals. I'm- why is?
Can I plug in the thing? Do you have a adapter?
Yes, I have it now.
Oh, but is it one of those things?
Yeah.
We don't have the right tools. Okay.
Which one is it? Is that one of those? This one or this one? It's one of those.
Are we gonna break it?
Let me see if I can find it too.
HDMI, right?
Yeah.
We can just plug it directly in.
Your laptop has one. It's like your older laptop. In the meantime, I'll try and see why it's not there.
Do we know why it's not working?
Go to your, yeah.
We're gonna be there soon, folks. Sorry.
Should have done it a different way. Oh, here it is. It's here. Dynamic flooding update. Why is it not? What's different about this one? It's,
Together?
So it did flash. We saw your screen for like 1
yeah,
second.
I'm gonna see why it doesn't. It should be there. Maybe it's the wrong order. I don't know. I'll check here.
Reload the thing.
This is
Okay.
a different page.
Do you have it on your laptop?
Yeah.
Do you have HDMI? Okay. Do you want to move to a different presentation while I can transfer it?
Sure. Let's go to.
We'll just switch to the next presentation and then I'll get yours up there.
Okay. You want to put it back in here then?
Yeah, just pull up whatever the next one is. And I'll upload
Yeah.
this.
You know, it's on the meeting materials. It's just not on the agenda. I don't understand that.
Oh, okay, well, I'll figure it.
that it? That's just the agenda, right?
Oh, yeah.
Here. Here it is. It's right there. Why in the fuck was that?
So, good morning. My name is Sarah Chen from Arista Networks. So I will give an update on dynamic flooding on dense graphs. First, a quick review. The basic idea of dynamic flooding is to decouple a relatively sparse flooding topology from the physical topology. This draft has focused on extending the existing link state protocols to support dynamic flooding in both centralized and distributed mode, without any restriction on the physical topology. This draft doesn't intend to define the algorithm for computing the flooding topology. These are the TLVs that have been introduced to support dynamic flooding with ISS and OSPF. It covers the area leader selection and flooding topology encoding. Since last meeting, there are many editorial changes, and also two important changes are made to this draft. We introduced new protocol elements for both ISIS and OSPF. And we'll also discuss the treatment of topology events in more details. In particular, we introduced the concept of temporary flooding. The basic idea is to allow the node to flood on the link that does not belong to the flooding topology. I will talk more about it later. Now I'm gonna go through the new protocol elements we introduced in this update. First are the ISIS TLVs. We introduced a dynamic flooding sub-TLV. So if a node supports dynamic flooding, it can insert this sub-TLV to its router capability TLV. And the knowledge of which nodes support dynamic flooding can help optimize the flooding topology. In this sub-TLV, the node can tell which algorithms it supports for flooding calculation. And this knowledge can help the area leader to select the algorithm in the distributed mode. We also introduced a new flooding request TLV. And this TLV is used for requesting temporary flooding from the neighbor node. This is the format for the new ISIS dynamic flooding sub-TLV. It's pretty straightforward. We have the type field, length field, and multiple algorithm fields. Each algorithm field is a numerical identifier in the range of 0 to 255. And it identifies the algorithm used to calculating the flooding topology. And we can have multiple algorithm fields here. This is the new ISIS flooding request TLV, and it may be included in the IIH. In the P2P mode, there's only one type of hello. So, but the node needs to tell the neighbor which level it wants the temporary flooding to happen. So here we added a circle typed field. The orbit and the scope field is meant for the nodes that support this IFC 7356. I will not go into details. Very similarly, we introduced the new OSPF TLVs, the dynamic flooding sub-TLV, which will be in the router information LSA for both V2 and V3. For flooding request, we propose option bit in the LS type 1, extended options and field. So here is the format of OSPF dynamic flooding sub-TLV. All the fields have the same meaning as those in the ISIs. Okay, so as promised, I will talk more about the temporary flooding. So why do we need temporary flooding? I will go through one example. Let me go through the first case. Let's think a new link comes up. Then the two nodes will form the adjacency and sync their link state database. These are all done using the existing protocol mechanism. In the normal case, both adjacency nodes are connected to the flooding topology, and this new link state update will be flooded on the flooding topology. But in some case, if one of the adjacency node is not connecting to the flooding topology, then this guy will not receive any link state updates until a new flooding topology is calculated, and it becomes part of the new flooding topology. So dynamic flooding still works, but it will slow down the convergence significantly. So we propose here that in this case, to use temporary flooding. It works like this. So when the new link comes up, if the node thinks it's not connecting to any flooding topology, then it enables the flooding locally, and then send a request to flooding to the neighbor asking for the temporary flooding. The neighbor, once it receives the flooding request, it will start flooding on this new link. The temporary flooding will continue until the new flooding topology is calculated and both adjacency nodes are connected to this new topology. So there's another case where temporary flooding can be used. So if a local link fails and this node has one or only or no connection to the flooding topology, it can also enable temporary flooding on one or a small subset of its links for fast convergence. But here, we do not recommend that this node blindly requests temporary flooding on all its links, because this might overwhelm the node itself and cause some instability. So as you can see that there's a trade-off during the design of dynamic flooding. On one hand, if excessive flooding may cause the control plane to overload and lead to network unstable. On the other hand, too less flooding may slow down the convergence. So there's no quantitative measure of how much flooding is optimal. So when we choose the flooding topology and enable temporary flooding, we should take into account this trade-off. And that's my presentation.
Okay, good. No comments? Oh.
Hi, Tony Lee, Arista. So if there's no discussion, the authors and design team would like to ask for working group adoption at this time.
Yeah, I think we just have to resolve one issue, but I think it's ready for that working group adoption call as well. I don't know what you the issue I think is that we have another draft out there that is very similar.
Yeah. Huaimo Chen from Huawei Technology. I think in working group, at least have two comprehensive, almost complete solutions for flooding reduction. And then we have, I think I remember in last IETF, we have discussions. Some of people propose merge two drafts And also, I think one of the child also have indication maybe merge, right? So I don't know whether we just one draft move forward, just left the other draft, and then those people also working very hard. And then I don't know, is that a fair or just the
Right.
So we need to have more discussions.
Yeah, so I knew this was going to be a little contentious. So I went back and I I looked at the timelines, right? And Tony published his draft on which was about a central controller and distributing a flooding topology on January 7th. Then the distributed flooding reduction draft was published in March. They both presented at IETF 101. The distributed algorithm was found wanting, right? There was problems that were called at the mic, like breakage of triangle topologies. And the point being that it wasn't fully baked, right? Tony's kind of was a little bit more baked. Then we had presentations during the transition to the next IETF. We had both works adopted sort of the concept from each other. Tony brought in the idea of distributed, which really was just eliminating the flooding topology and putting an algorithm field in. And you added in the centralized solution. So, and you also had a distributed algorithm, which would still fit within Tony's work, right? He's not, or Tony et al. They're not defining distributed algorithms. So I think one way forward here would be for you to work on the distributed algorithm that you had thought of before, right? And that would then not conflict at all, right? But to have to, basically the other thing is that, you know, I mean, this is my opinion as a member of the working group. Tony's draft is really well written. And it also, and also the flooding topology distribution is very much a KISS solution, right? It's very simple. And this is just my opinion as a member of the working group. When I look at your solution, it seems a lot more complex, right? And I'm not sure what the win is there. So anyway, that's my opinion as a member, and also the history here. So I would hope, you know, I think that one way forward would be for you to work on the distributed algorithm that you had thought of before, and then that can advance in parallel, and then we have no conflict. I don't know what other people's opinion are.
I think regarding the dates, I think there's a meeting or there's a proposal in some kind of, I think Jeff hosted the meeting regarding the requirement for data center, right? So from that point, and then people working on the flood reduction, and then the days. First, we also presented the flooding reduction on IETF 101, right? And then I also remember that some people think distributed one is more practical, and that's the different opinions, right? And also, I think we have, regarding the solution, people also have different opinion. This solution is better, this solution is simpler. I think maybe after both drafts presented, and then we should have discussions from technical point of view, for whatever point of view, and then I don't know whether we can have discussion, which one is better, which one is simpler, or maybe combine together, maybe can improve one draft or another, and then have a whole solution is much better. I think for those different approaches or options, we should have some discussions, right? Either is a centralized one, go one draft, and distribute one, another draft, whatever, or merge it together.
Speaking as a chair, I like the way that Tony, that Chris said, positioned the drafts. So that way we'd have this draft at the top as for dynamic flooding, and the two flavors, centralized and distributed. And your draft would be one distributed algorithm, and the one that Gunther's going to present would be another one. And I think that would allow all of them to be positioned and go forward. So I'm supportive of that, speaking as chair, because I lived through the Monet 3 drafts, as Alvaro did as well. And we don't want to adopt multiples and say, okay, let the best man win it, because sometimes they go on, BPLS was another thing. I mean, where they had two different signaling solutions, and they both went on, and what it did is it diminished the value of both of them. And in a Monet, what we had to do at the end was they all became experimental, and they kind of fell into obscurity, and we definitely don't want to lose this work. And I think I'd support Chris's straw man, and maybe we could put that straw man and discuss the straw man he's got on the list and why not, rather, because we're going to run out of time. I think that's what we should do.
Yeah, I think right now the Tony's draft and our draft, I think, resolve the same issues, right? I think it may be just a different approach, and some are different and some are the same. I think
Okay, thank you.
Are you finished, Stacy? Chris? I was just going to say, that, in terms of splitting the algorithm work from the mechanistic part of it, it seems to be the piece that makes the most sense. So just Chris Martin from Arista, I think that would be the better approach. I just want to make that claim.
Yeah, Gunther's next, then you.
Yeah, about this. So I'm Jabberscribe. I'm sitting here typing in your name as you're up here at the mic. If you don't show me your badge, people in the room don't know who you are. Yes, but it's like
Is it in the mode where
it's like I call it. So make sure your badge is fully visible. Thank you.
Oh, okay. Oh, fit the page. Okay. Yeah.
It took me like 3 presentations to figure
Yeah.
out all this stuff.
Can I?
Yes.
Okay. So I'm here actually to speak about like yet another, flooding reduction technology here. It is something that, comes out of the brain of Hank Smith. So, he wanted to present here, but he couldn't actually make it. So this is something we started to work upon since the last, IETF in Montreal. And we were actually thinking like, okay, we have some flooding, reduction algorithm already out there, but there might be a way to actually, make it even more simple. The word simple was already mentioned before. We like simple. Simple are good things. And if it can be implemented also on the router, running already ISAS, and if the router can be extended with like something, very simple, like no additional SPFs, no complex signaling, something that just follows the traditional routing, I think that would be a simple solution. So that's what I'm going to be presenting here. So what we're going to be doing here, I'm going to be talking about something which is like fully distributed, something which will work across any kind of topology of what you have available. And I will just hope that my explanation will justify the simplicity of the work, because I tend to think, I tend to explain things more complicated than they actually are in reality. So I'll do my best. So, yeah, so in essence, what we are going to be doing here is if you have like 2 boxes in the network and you're connected with multiple links, then what we really would like to have is that, that we don't flood across the links between all of the links between those 2 boxes. We would like to have like one of the links between the 2 boxes which is used for flooding. So that is the master plan. And to actually achieve that, we use like TLVs, just like in the previous proposal. And we also use something, so one TLV is going to be used to identify a flooding anchor. So the technology, what I'm describing here, is based upon creating a flooding tree. And the root of the tree is going to be our flooding anchor. So that is going to be basically like a simple TLV. I will explain a little bit more about it. That TLV will be set in the LS. It will be, part of the LSP, and it will indicate it's an anchor.
Gunther, quick question. Yeah. This AC Linda. What is that? The only thing it reduces is parallel links. It reduces ECMP, right? Like in a CLO network, true, doesn't it?
Yeah.
Okay. Okay.
I'll explain later.
That's what I thought. Okay.
I even have pictures.
Pictures are good.
Pictures are good. I don't only have text, I have pictures also, so I'm like super advanced here. So, and then the other extension I have is, if a particular router determines, what is going to be his, best link towards the flooding anchor, so that's a local decision, he actually needs to signal it upstream towards the anchor to tell the other guy that he selected that particular link as the flooding link itself. So to do that, we actually, use like another TLV in the ISH. So I'm going to be skipping this. I'm going to be jumping directly to pictures, okay? Because people like pictures. So what you see here on the classic flooding, so you see the router, router 13 here in the middle, sorry, router 23. So assume router 23 gets like a new LSP. He actually ships it upstream. That's the blue arrow. It goes to the router on top. That router actually, depending on if it is newer or not, it will actually send that LSP, to everywhere, and then the everywhere will send LSPs back. So you have like this flooding storm thing going on. Now, that is not very optimal. So that is what we would like to avoid. So what we will achieve here with our minimal flooding, so is the desired behavior. That if router 23 creates like a new LSP, that actually, ships it up. 22 in this case. I missed routers. Okay, it doesn't really matter. So on router 22, because like a new LSP, it ships it up. And that only the blue lines actually are part of our flooding topology. So it actually, router 12 will then just ship it over towards router 11 or router 13 and so onwards. So the blue lines is actually a minimal flooding topology. Now the big question is, how do we go from the classic thing towards the minimal flooding thing? And that's what what we actually came up with. So how does it work? So the first step, you see the topology here. So again, the topology what I'm using is just a random topology. By the way, am I going quick enough, or I need to go faster? Because okay, I will go faster, so it will become more complex. So I have like I just select one of the routers in my network as being the flooding anchor, and that guy will set this TLV saying like I'm the flooding anchor, and that LSP gets flooded everywhere. So the first step that happens is for the routers directly attached to the flooding anchor. Actually, they will say, okay, I know who the flooding anchor is now. Which interface points towards the flooding anchor? And that interface, here, for example, here, you actually say, okay, on this interface, I would like to do flooding, and on the other interfaces, you're actually going to be doing flooding suppression. Now, that is very good if this guy gets an LSP, and he wants to ship it up. But of course, if there is an LSP coming from somewhere else, like from here, it needs to go down also. So the upstream, the router going up towards the anchor needs to be aware about which is the flooding, the flooding link. So that is why we use the IIH, TLV extension, so that this router, this link local, can signal towards that guy, I'm going to be using this link as my flooding link. So the same kind of principle is actually happening, consecutively, like, different times. And that is what you see actually in this picture. So what you have in this case, you create from your very, very dense, diverse kind of topology, a topology for flooding just for the control plane, something like this. What you see here. And all of the control plane, all of the control plane information will actually have to go over the anchor. You can actually have one anchor, but if that actually fails, you will actually fall back to traditional flooding, which is maybe undesired. You can actually, set up a secondary anchor, for resiliency in your infrastructure. So it actually works very well. So what you actually, what we're doing here is, we actually, in essence, if you look into it, the way we actually are distributing our LSPs and control plane traffic from a routing perspective is very similar to what you actually do with like a ping sparse mode tree towards the rendezvous point. It's only used for control plane packets, not for data forwarding at all. You don't need any additional, SPFs or anything else complex. Signaling is, relatively simple. So this is again what I explained for having a more robust, topology. So I also added like a bit more information about what we would like to add in the TLVs. So the first TLV, so the anchor TLV, so this is the TLV used by the anchor to signal everybody else in the infrastructure, I am the anchor. So the first thing you have to put in there is like a priority, it's a priority field. To actually, if you have multiple anchors, to actually let the network know which is the most important one or the one which is most desired to become, the real floating anchor. And then a second field is like, to let everybody know how many flooding topologies you would like to have. Then in the ISH for the hellos to actually signal link locally between two routers, which is going to be the flooding link. So again, a very simple TLV. You're going to put like we were thinking about putting 3 different values in there. The first thing would be like a flooding suppression indicator. So this actually would be the adjacent the router itself determines which is going to be the link pointing towards the anchor. And that actually you're going to be setting in there, like, okay, this is going to be the link, it's going to be suppressed, yes or no. Another field would be, in there to actually give the actual suppression itself, the actual suppression on the link, which can be used for a troubleshooting kind of perspective, which could be very handy. And then a third, piece of information which is in there is, if you want to have like a bit more advanced, algorithm or whatever in there, like the number of active flooding adjacencies. This actually can then be used to optimize your flooding topology based upon the degree of connectivity. So that is something we can do. It's also fully backward compatible, so you can actually introduce this, gradually if you desire to do that. And in essence, what it results to is like, if a router doesn't really support this and it cannot inject the ISH, the hello TLV, then there is no flooding suppression, and we just fall back to classic traditional flooding at the node itself. Anyway, so we actually have some other additional text written up already. If you actually go flooding between trees, in essence, you will have to make the eternal trade-off. Trade-off being either you go for high speed or you go for stability, which actually means you go a little bit slower. And that is a trade-off we're actually going to be making also. The going slower will be based upon the degree of connectivity. So I think I'm going to be leaving it over there with this slide on the thing, because I see AC, almost kicking me, out of stage. Any questions, comments, and so onwards?
I have a question. Does this actually just end up computing a minimal spanning tree?
It computes like a sparse tree, but it actually just like around the like a multicast rendezvous point. So you create like a tree, but you don't do it based upon like any kind of SPF or whatever. You use the information of what you have available. You know where the anchor is. Just select the link which is most close to it, and that's it.
Yeah, no, I understood the mechanism. I was just wondering if the result was that you ended up with that.
Les Ginsberg. So in the spirit of Chris's proposal to take all of the multiple drafts, because now we have one more.
Yes, one more. Yep.
Do you see any reason why we could not take whatever ideas are relevant from your draft, incorporate it into one draft which represents the mechanics of the flooding topology, and have other drafts which work on the algorithms? Do you see this as a reasonable way forward?
So I see that's a good one. So the reason we created this draft is because it's actually, if you look into it, because Henk he's written some IIS code like in the past, we actually envisioned this as being like relatively simple to implement on an existing IIS implementation. Okay, now if we want right now the idea is just existing is sort of like being created. How to move this forward, knowing the like multiple drafts, I don't, I can talk to you afterwards, not a problem at all. We can figure that one out.
I will cut the mic after Chris.
Hi, Tony Lee, Arista. So I'd like to reiterate some comments that we had in private email, but just for the benefits of the working group. My concerns with this are all about the diameter of the result and also the degree. The diameter is key because that controls the speed that the flooding is going to give you. A graph with a very large diameter, your LSP flooding is going to have to take many hops, and that's going to impact convergence. The degree, if the degree of the node is too high, and especially in this case when you've got redundant anchors, you could get an anchor that gets flooded by an LSP update, and that could cause instability at that node. So those things are both things I think need to be addressed.
Yes, and again, Tony, that is why while I mentioned like in the next version, we have some text about it which was like inspired by your comments, and that's why we have like some sort, we have a solution which trades off speed by convergence. Yes.
And Chris Bowers. So I just wanted to point out that I'm very supportive of this. It doesn't really seem to me that it fits into the framework of Tony's draft or Tony et al.'s draft, in that it's not just a distributed protocol, but it's distributed plus some signaling with these TLVs. So it's not just like a subset of that, I believe. That would be my take. I mean, I think it could be made to be one overarching thing, but I think there would have to be work to accomplish that.
We really have to, we're like 10 minutes over.
Sorry, Chris Martin, I just wanted to say one thing, because Chris came, so I gave him my spot. Back to Tony's point, the nature or the notion of a flooding tree is kind of, I don't want to say it's obvious, and Gunther, I don't mean this in a bad way, so we could have, I mean, obviously that's the first step you would take. I mean, it doesn't seem to be, the coverage is not the same. I think the resiliency is not there and the diameter issues are there. So I just wanted to make that clear. I mean, we kind of thought of it right away. I don't know if it's the best approach. Thanks.
So where's that? You got it? I think this is it, right?
Yeah, that's it. Where's the thing to make it full screen?
Oh, this is a different thing.
Oh, okay.
This is yeah. When Jeff said don't do this, what he meant.
It's not.
But we're just gonna have to run with it like this,
Yeah.
I think.
Where's the view? It's not a map.
Yeah, but why don't we just go?
Can I start?
Go.
Yeah, I'm Huai Chen from Huawei Technology. Today I'm going to present link state flooding reduction. So this covers OSPF and ISS. Next page.
Okay, maybe we can't do that.
So in version 0, so we focus on distributed mode for flooding reduction. So in addition to that, we also talk about centralized mode and the static mode for flooding reduction. That's in our 0.0 version. So in our 0.1 version, we made extensions. So we allow operators to select a mode. They can select distributed mode, centralized mode, or static mode. So we can also allow customers to select algorithms for computing flooding topology. In addition to that, it also allows customers to enable flooding topology, for flooding reduction, also roll back from flooding reduction to normal flooding. So after version 0.1, we deliver a couple of versions which address comments from the list and from the IETF meetings. And then right now, we have a 0.4 version. So in the current version, we have this stuff. One is that for both centralized version and distributed mode, we have backup paths, which can be used to backup flooding topology split. So for centralized mode, we have messages for flooding topologies. So including a couple of flooding topology encodings. And then we have encodings for backup paths. And then we have, in this draft, we have extension for all different IGPs, OSPF version 2, version 3, and ISS. Next page. No, not all.
I'll run it.
So this is for backup for flooding topology split. So when we construct a flooding topology, normally we have two objectives. One objective is that we would like to have a flooding topology, and then which can be used to reduce the flooding greatly. So in this case, we should have a slim flooding topology. That's one objective. At the same time, we also would like to have a flooding topology, which is kind of a reliable, means tolerance to failures. So in this case, we need to have a flooding topology which is very fat. So this is a contradictory, right? So it's very hard. So in order to get around this, we propose a backup path, using backup path to backup flooding topology split. So in this way, we can have a first link flooding topology. At the same time, we can also achieve fault tolerance. So for example, for a critical node on the flooding topology, if we can compute a backup path, when this critical node is down, and then we can flood the link state using the backup path for that node, at the same time, the remaining topology. So we can quickly flood the link state to every live node. So using this way, we can also achieve fault tolerance for multiple failures. So for example, if we have multiple failures, node failures or link failures, so in this case, we can use backup paths for this failure node or link, and then at the same time, the remaining topologies. So we can flood a link state using remaining flooding topology and then the backup path. So in this way, link state can quickly distribute to every live node in the topology. So next page.
Oh, that is not speedy.
So this is the message for the flooding topology for centralized mode. So we know for flooding topology, which can be represented by the links on the flooding topology. So those links, we can very easily encode it. So we can start for each node, we know there's a links attached to that node. So we can just encode that node, we call the local node, and then the remote node, which is connected by that flooding link. So for each node, we encode the local node and then the remote node. So we just use a node index. In addition to that, we can also give the size of that node index. So in this way, we can achieve a very efficient encoding of the links. For here, we give an example. For example, we consider local node with short for LN1. So we have 3 links on the flooding topology, which is the green link. So to remote node 1, remote node 2, remote node 3, so 3 links. In this case, we have encoding for local node LN1, and then we encoded the remote node, which is 3 node 1, remote node 1, remote node 2, remote node 3. So 3 links. So local node index, and then plus the number of nodes, and then the 3 node index. And then we also give the size, indication of the size of the index. So in this way, we have very simple and efficient node link encodings. So next page. So for each node, for the links connect to the node on the flooding topology, we encode the links. And then all those links, we can put it in a TLV, we call the flooding topology link TLV.
You're already at about 8 minutes.
Yeah, almost done.
Okay.
And then this TLV can put it in the flooding topology opaque lattice, and then we can flood. That's the flooding topology encoding. Next page. So this one is an improvement for flooding topology encoding. So we can just encode the whole part topology or whole flooding topology in one data structure. In this way, we can have a more efficient encodings. Next page. So this is encoding about a backup path. So we have encoding for backup paths for node, and then this is also very simple. Just we have encoding for the path by node index, right? And then for each node, we may have a number of backup paths, we may have multiple paths, backup paths, and then for each path, we have path length and then the list of nodes on the path. So for this backup path, we can put in the TLV, and then this TLV can be put in the OPAC LSAs. So similarly, we can do that for the backup for the link. So this is only for used for the centralized mode. So we can see that we have a backup path for flooding topology split. So in this way, we can achieve the objective, reduce the flood topology, link state flooding significantly. At the same time, we achieve the fault tolerance. And also, we have the encoding for the flooding topologies. We give us a couple ways, options. And then I think this one is also very simple and efficient. I think also, so regarding the one, we have a solution for centralized one mode and also distributed mode. I think this one is also comprehensive solutions. So regarding this one, I would like also ask with options because last IETF, some people propose merge. I think it's a good way to merge because same problem and then maybe different solutions and then cover different ways and then maybe it's better. That's my opinion.
Okay, I don't think we have time for too many comments. I guess we're going to have some discussions on the straw man and how these drafts relate. Dave, can you do 10 minutes instead of 15? Okay.
Okay, thank you.
Thanks. This is being presented in another working group too, right? No? Oh, shoot.
We tried to get it on a couple of other agendas, but didn't quite happen. Anyway, this is a problem space that I found really, really interesting, and there was stuff from something I'd done in a past life that I thought was applicable, so I thought I'd throw my hat in the ring or Shark Tank or whatever you want to characterize this exercise as. So anyway, I have a distributed algorithm for the constrained flooding of IGP advertisements, and it kind of, oh, not that one.
Oh, what is this? How did that?
I don't even know what half of those acronyms are.
How did that happen?
I don't know. I swear I thought you just did the right thing.
Yeah, I thought I just did the right thing.
Whoa.
Yeah, it's,
No, and I
Oh,
don't
I see
have
what-
the
I see what
encoding in my
happened.
draft either.
What happened?
it must have.
Are we so over time it went to the next?
No. What happened was it
Well,
went.
this is eating my time.
There's other tabs open. That's the problem.
Okay.
And it went to the next.
Yeah.
I hate the way that this.
It's right above.
At any rate, well, they're solving that.
There's sorry. It says no.
Okay.
Grow.
Just close those tabs.
Okay.
Yeah, and we don't want the agenda. We want the materials. What happened to my materials?
That's what I'm saying. I don't know. I have no idea what.
Here.
Yeah, is it? Wow, we really don't have time for this.
No.
I'd started into my plot, but I think I would lose myself along the way. So
Here's one.
you're going to have to bear with me.
Yeah, I'm starting to think this like pre-set up laptop thing is not that useful. I mean, really, like it just worked better when we used our own.
Okay.
Oh, look at what did it do there?
When you tried, it didn't work so.
Yeah.
Hurrah.
Well, that's because I didn't have.
Okay, I had it here.
Okay, next trick.
That and then went to grow.
Okay, here.
Oh, even better. Okay, so Tony brought forward this sort of general problem on how to produce a constrained flooding topology for dense graphs, something that would be immune to single failures and would reduce the number of copies of an LSA that would be continually interrupting the control plane. What this draft discusses is a distributed algorithm for computing the flooding topologies with desirable properties. I have only really looked at it for bipartite style graphs, which actually could be, with multiple hierarchies, and the modified ones with intra-tier links. It may be applicable to other topologies, but that would be for further study. My understanding, this was kind of the problem space at the moment, so that's what I focused on. What the approach is to use two diversely routed spanning trees such that each node in the dense graph is biconnected to the flooding topologies. The spanning trees are computed by each node, or that each node figures out what its role is in the spanning tree by computing it from the basis of information that's in the IGP. The flooding topology itself is the sum of the spanning trees. So for example, the first copy of an LSA received by a node, it doesn't care which spanning tree it got it from. That's the one it propagates, and of course the next one is considered to be redundant and thrown away. Because the key thing here is I'm trying to achieve resiliency with nothing being able to think. So in essence, it's a 1+1 arrangement for flooding, and everybody gets two copies of everything. The actual flooding itself is split horizon between upstream and downstream for LSAs received from an upstream interface, and that's one of the ways we explicitly constrain flooding. And like I said, the net result is in a fault-free topology. All nodes participating in the flooding topology will receive two copies, and even under single failure scenarios and many multiple failure scenarios, they will receive at least one. What makes it work is the tie-breaking algorithm from 802.1AQ, which is also documented in RFC 6329, for those of you who want to see the IETF version of it. And when we worked on the algorithms for 802.1AQ, I guess 12 years ago now, one of the things we did was we had tools for visualizing the networks that we built. And one of the things that was embodied in this was the idea to, if I wanted to do load spreading, and this was originally for Ethernet, we had this notion of an algorithm mask that would be involved in the tie-breaking algorithm, and therefore we could do different variations of tie-breaking. And when we used the bookends of the tie-breaking algorithm, then we got, in most networks, very or completely diverse trees out of the deal. Now, the actual tie-breaking itself is you take the algorithm mask, you XOR it with the lexicographically sorted list of node IDs in the path, you rank those and select the either the lowest or the highest, depending on what you're doing, and that is your tie-breaking. The interesting property of this is that any component of the shortest path is also the shortest path. And what that means is as you're traversing a graph, you can ditch an awful lot of options. So this thing is n log n in complexity, but not all n log n's are equal, would be my observation. And this one is really, really quite frugal of resources. To give you a visual representation, this is what the flooding topology would look like. It's based on one spanning tree rooted at 0, which is the red one, and it's constructed using the low tiebreaker. So you'll notice all the transit nodes at any given distance from that route is the low node ID. And the other one is rooted on 55, and it is using the high ID. So all the transit nodes for the green tree end up transiting the high ID of any given set of nodes that's equidistant from it. The net result is that everybody is bi-connected to the flooding topology, hence they will receive two copies. Now the flooding rules themselves are really quite simple. If an LSA is received from an upstream adjacency and it's the first copy you've received, flood on all downstream member adjacencies. And if you are also connected to nodes that are not participating in the flooding topology, you use normal flooding rules for those particular adjacencies. Those are described as non-participant adjacencies in the draft. If I'm received from a downstream adjacency and it's a new LSA, flood on all the non-participating adjacencies and all member adjacencies except the adjacency of arrival. And so this is examples are illustrated at the bottom here. And the key idea is that although I've illustrated them as the red and the green spanning trees, in essence, we're dealing with the sum of them. So there is no protocol changes to the actual LSA flooding itself to make this work. Now, the required protocol changes, I need the ability of a node to advertise that it wants to participate in the flooding topology in the IGP. This would be some form of capability TLV. And I would need knowledge of the routes. Ideally, that would be advertised in the IGP, or there would have to be sufficient information to allow some form of distributed route election. I don't actually solve that problem. I simply provide a lot of stuff on what is required in terms of what any means of route selection would need to achieve. Now, probably the key limitation to this is I do not bound the number of copies that a node needs to generate. I bound the number of copies a node will receive. But for example, if I look at node 55, it will generate, what is it, 8, 16, 24 copies it will have to produce to send. It's only ever going to receive 2 copies, but it has to send, and that is a function of the physical topology. That's not something that's artificially constrained. Intuitively, the only way I can constrain that is by extending the flooding diameter, and I considered that to be undesirable. So the draft contains a discussion of the problem space, provides the algorithms, the flooding rules, a discussion on the requirements for route selection, how to interact with non-participants in the flooding topology, has some discussion about re-optimization. Right now, the whole idea is I'm trying to maintain a fully redundant structure at all times, which means when failures occur, at some point I'm going to have to go and clean it up afterwards and proceed to restore full 1+1 failure tolerance. It also suggests some strategies for dealing with catastrophic multiple failures, where, for example, the extreme worst case would be losing both routes simultaneously. The draft doesn't define the protocol elements at this particular point in time. It simply discusses what is needed. And like I said, it doesn't define route selection procedures. It only provides what the requirements are for the routes relative to each other. So just very quickly summarize the characteristics of the solution. The structure of the flooding topology is interconnected 1+1 multi-point to multi-point trees. The protocol changes requirement are an advertisement of the 2 routes, an advertisement of the desire and the capability to participate in the flooding topology. The computation that each node has to do is order 2 times n log n, but like I said, that's a relatively frugal n log n in the spectrum of n log n's that are out there. The maximum diameter of the flooding topology is twice the distance of leaf to spine in a fault-free network. And in a single failure worst case, it's twice the distance from the leaf to the spine, plus the distance between the roots -1. Because the worst case is when it's a inter-root link that goes down, or a node on the inter-root path, which means things need to fully loop back around such that every node in the network sees a copy of every LSA that needs to be flooded. And the typical and maximum number of LSAs a node will receive will be 2. So next steps is I've done a bit more thinking about the route selection. I want to document that. And otherwise, I'm just interested in collecting feedback and figuring out where we go from here. And it looks like that's going to be a fun exercise. So, Tony.
Tony P. Juniper, right? Discussion open. So I didn't look into all the super gritty, nitty-gritty detail of the algorithm, and I wasn't actually aware that this work has been done until I saw your draft circulating. So I basically went after the thing in a more by gut feeling what the properties of this thing will be. And one thing I'm confused about, so will that produce the lowest diameter tree, or will that stabilize on a not necessarily lowest diameter? Because I saw this tie breaking, but I didn't understand whether it's like a spanning tree that tie breaks to the point it has an optimal solution, or whether there's some stability point.
It's on the shortest paths, and seeing as we're discussing tree networks, I believe the diameter would correspond to the minimum physical diameter.
Okay, which is not the shortest tree, but the shortest path. Okay,
yeah.
Fair enough answer. The other question is, did anybody do any work choosing a route per originator that you reflood?
I don't. We did look at that when we looked at multicast some time ago.
All right, so
back in the .1AQ work. I did consider it in this case It's just that I ended up going at the 2 spanning trees because I could still produce failure cases with a root per originator that I did not think the resiliency would cover. I can't remember why I ended up thinking that.
I would be very interested in discussion because right now, I mean, you don't have any fan-out control, right? A degree control on the node. Whereas when we go in this direction, you could possibly address this problem. And otherwise, yeah, elegant work. Thanks.
Okay, thank you.
So we'll go to the next one. Obviously, we're not going to do standardize all these different distributed algorithms, but one criteria, I think, ones that are implemented and have implementation results would be preferred over ones that don't.
Question for you, not for Dave. Or you go ahead, Chris. Sorry.
No, I was just going to say, I mean, I think that not just the implementation, right, but it also differentiation, right?
Yes.
Like the sparse links and the spanning tree look very similar. Like, I mean, they're not exactly the same, right? But
Except one is done by handshaking and one's done by computation.
Right.
So.
I'm over with Routing. Just a question for you guys on what's going to happen next. So there's this straw man on separating the algorithms from the rest of the work. There are several proposals. You said that maybe there's going to be an interim. You also said that you're going to discuss the proposal on the list. Is that going to happen first and then the interim? Or are we going to discuss everything on the interim? That decision of we only are going to choose one, is that part of the proposal? Just so that everyone knows what's going to happen.
So I think that there's 2 things to discuss. As long as we can agree to separate the 2 things, then we can have I think you have to agree on that first. And then we have an interim based on the results of what,
right,
what that is.
We've already agreed to split out the spine leaf optimization on its own as a small incremental 1-level flooding optimization. Now, we're going to put the straw man for distributing the centralized and distributed algorithm frameworks. And then I think we should at least have an interim so everybody can talk.
I mean, I think the interim is most useful about the algorithms, right?
Yes.
I mean,
Okay.
I think we just need to settle this 2 drafts covering the same exact technology, right? I mean, it's we don't need two drafts to do that. So we settle that, and then it's a discussion of the algorithms, whether it's centralized or distributed.
Right. Les? I actually think we're not as far behind as I thought.
No, and we could. I mean, it depends on how if we want to. We can shorten the break, but I don't. Maybe people yell at us.
Yeah. You can go faster. I read this draft. You should be able to do faster. I mean, you should be able to do faster.
Can you do full size, or is that no possible? Okay.
No.
This is a bit of ISIS 101, but it seems that there's some reasons why this draft was written because of some real world events. Are we not able to go
No.
full screen?
Apparently, we need to do PDF from now on if we're going to use this dumb thing.
Okay. So what were the motivations for this draft? There was some discussion that it's hard to find an explicit statement about what to do when there's a TLV that's not supposed to be in a particular PDU. There have been some interoperability issues actually seen in the field. Things such as LSPs being rejected because there were unsupported TLVs or sub-TLVs in a particular LSP, or a TLV was malformed. The purge handling has several modes because of past work, and there's been some confusion around that. This leads to some significant operational problems because you can end up with inconsistent LSP DBs on different nodes of the network, and then clearly your routing is broken. Oh, I can't do this? Okay. So what do we have? We have a TLV code points registry that looks kind of like this. I only used one example TLV. Gives you the value and the name and what PDUs the TLV is allowed in. Yes in a column means this TLV is allowed in this particular PDU type. A no means it's disallowed. The question then is how to handle the case where a TLV is in a PDU that it's disallowed. Next. So if we go back to the base spec, 10.589, there's a statement in there that says any codes in a received PDU that are not recognized shall be ignored. Well, unsupported and equals disallowed because maybe my implementation supports TLV, but your implementation does not. And I cannot expect you, if I'm going to be able to roll out new TLVs hitlessly, I can't make decisions on the assumption that every node of the network understands what this TLV is like. So if I get a TLV in a PDU and it's not supposed to be there, then I need to ignore it as per the base specification. And that's what this little table is showing. Let's go to the next slide. So it's critical to remember that the unit of update for ISIS is an LSP. It's a PDU. It's not a TLV. When we say we accept the flooding update, we're not saying we accept every TLV or we understand every TLV inside the LSP. We're saying that the LSP itself has passed the validation checks. What are the validation checks? There's a checksum, there's authentication, which optionally may be used. And then, of course, there's the rules as defining is this LSP newer than what I have in the database? If it's not, then I need to send the newer copy. If what I have is older, then I need to accept it. Key point, TLV content is not relevant in terms of accepting the LSP. The validation checks are on the PDU level, not on the TLV level. Next slide. So what interoperability issues have we seen? You have a case here where you start out and node A has sent an LSP with sequence number 99. Everybody's happy. Then it generates a new copy, puts a TLV in there that is in some way bad, doesn't follow the specification in some way. What happens? B follows the rules. He looks at the LSP and says, well, the checksum is fine, the authentication is fine, I will accept this. Then he sends it to C, and C goes, gee, this TLV is not to my liking. I'm not going to accept the LSP. So what do we end up with? We end up with nodes A and B that have version 100 of the LSP, and nodes C and D that have version 99. This is clearly non-functional. Next slide. Purges get to be a little more complex because we start out with the base specification 10.589, which suggested that, well, if I go to purge an LSP, there's no point in keeping the content, the TLVs that are in the LSP, but it didn't actually require that the TLVs be removed. It just suggested that that was a good policy. So if I get a purge based on 10.589 rules, and it has some TLVs in it, I can still accept it. If it has no TLVs in it, I can still accept it. When we moved to cryptographic authentication, that was no longer possible because it meant that an attacker could simply disrupt the network by setting the remaining lifetime to 0, not changing the content in the LSP at all, and the authentication hash would still pass. This was clearly broken, so 5304 stated, okay, if you're using cryptographic authentication, the only TLV that you can have is the authentication TLV. And 5310 followed suit. When the purge origination TLV was introduced, we now had an additional case because we needed to allow a new TLV in purges. But if we followed 5304 rules strictly, then anybody that's following that would say, oh, this has a TLV besides authentication, I cannot accept this. So this was not backwards compatible. So implementations that support POI have to have some way of allowing the operator to enable or disable the use of the POI TLV when cryptographic authentication is in use. Note that if you're not using cryptographic authentication, you can go back to the base 10.589 rules and say, well, Okay, anybody should be accepting a purge regardless of the TLV content. Next slide. So what are the POI implementation issues? Again, not everybody in the network may support POI. So you need some control to enable the use of POI when you're using cryptographic authentication. If what we then did as part of this POI support, we added the possibility of other TLVs perhaps being allowed in purges in the future. And in fact, that has happened. We now have 4 TLVs that are allowed in purges. And that's why there's a column in the code points registry that I showed on the first slide, which says, hey, this TLV is allowed in a purge or it's not allowed in a purge. Again, in order to be extensible, if I add a new TLV that's allowed in a purge, but somebody else out there has an older implementation and they don't understand what that TLV is, I could have an interoperability problem. So if I implement POI support, I have to do it in such a way that I can say, okay, there's TLVs that I know about, and there's TLVs that were not defined when I wrote my implementation, and I don't know about them. The ones that I know about, I can say, based upon the state of the registry, when I wrote my implementation, this is allowed in a purge or it's not allowed in a purge. The TLVs that get defined later, my implementation doesn't understand them. I cannot predict whether they're allowed or not. I have to ignore them when I receive a purge. And next slide is an example of the interoperability problems that happen with purges. I think maybe in the interest of time, we'll not go through the steps. Again, this draft is written for clarification. There are no protocol changes introduced by any of what the draft talks about. This is just trying to make things clear. And especially so because we have had interoperability issues in the field. And we're just trying to make sure that that's less likely to happen.
Tony P. Juniper, the last thanks for doing the dirty laundry again. We shall be not in need of those drafts. That's the second one you're bringing, right? Yeah. Highly encouraged, absolutely for adoption. If you need any help, co-authorship, we're here. Thanks.
That's on my mind, Tony, in fact.
So, just interrupt. Great work, very much needed, and hopefully foundation for really security framework that could be also formal reference. Anytime you write new draft here and our friends from security ask what happens when, I've got formal reference say, this tells us what happens when. So great stuff. I'm looking forward to OSPF as well.
Okay, thank you. One of the...
Oh, security, okay. I thought you meant the invalid TLD. Okay.
But one of the reasons for writing this was so that new drafts would not have to repeat this content over and over and over, just references.
Yeah, Michael Abrams, having been bitten by this kind of interop issues 10 years ago with IPv6 enablement, where it would drop the entire, packet just because it saw an IPv6 TLV, and there, yeah, please, I would like that not to happen again. I had to spin up a second IGP to do my IPv6 in a rollout for 2 years.
Okay, great. It looks like we have a lot of +1s on this being great. In just of time, let's move to the next one.
I'm Shraddha from Juniper. So I have a question on the allowing unknown TLVs in the purge. So are you suggesting that an implementation that does not understand a TLV in the purge, it should, if it's authenticated, you should accept it? Or are you suggesting any other TLV should also be accepted?
I'm saying when you write, you have version N of your implementation. At that point in time, you understand some set of TLVs. A new TLV can be introduced after your implementation was written. Clearly, you don't know whether that TLV is allowed in the purge or not because you just don't understand it. So you have to accept it.
What if a TLV that I understand has now is being allowed in? There's a new draft that allows that TLV in the purge for some reason.
Okay, then I think that's another, we're introducing a new backwards compatibility problem, and we would have to, if we wrote such a
because
draft,
that
we would
has a
have to define
security
the way.
issue, right? You cannot
Yeah,
accept.
yeah, agreed, agreed.
Okay. Go ahead. You can summarize.
No,
Okay.
Okay.
Do 10 minutes instead of 15?
I may even do faster.
Okay, good.
That is allowed.
Yes.
It's allowed. Okay. So this thing actually, is. I don't want to go there. Okay. I don't want to go there. So this idea actually, is something, what I believe is relatively simple, and and if you look into it, it's kind of surprising it never popped up before, because we see like a lot of proposals to improve all of the floating things to improve our convergence time. But there is like another component, with IGP routing, which can really speed up convergence significantly. And if you look into how the flooding actually is operated and the way our IGPs actually do the flooding, so they actually, take care of the packet pacing, they take care of reliability, retransmission, and so onwards, and it actually has been unchanged since, the origin of, the technology itself. Now, the way technology progressed, we now have TCP, and it sort of made us wonder, like, okay, why do we actually first want to, improve our flooding topologies, but not really look into, like, how routers do the flooding of control plane information between the routers themselves. So we said, okay, maybe let's have a look into TCP and actually, use and outsource all of the flooding stuff into TCP, let TCP take care of the retransmission and the packet pacing and then the reliability and all those kind of things. So that's what we're doing here. So, so the proposal what we have here is for ISAS. I'm pretty sure we can do the same thing for OSPF, but at this point in time, we believe at least, let's look at ISAS first. So in essence, what it is about here is indeed, between two routers to exchange LSPs and to use TCP as a communication channel for that. Now, to actually do that, the two routers need to agree between each other that they actually support, exchanging, all of the, flooding information over the TCP session itself. So we define like a new TLV for that in the ISH. Now, at the same time, because we also believe BGP is like ultra cool, and it also uses TCP, and it's a TCP byte stream. We also, and BGP is using some sort of like a synchronization marker header, in the TCP. We actually said, like, if we go down the road of using TCP for our control plane information, we should do the same thing as what we have in BGP. So we're going to be defining also like a small marker to have synchronization in the byte stream, very similar to the way BGP is using it. So if you look into the different scaling factors of ISAS, so the first thing we have is like, okay, each router has like a number of adjacency, like neighboring routers. We cannot really do that much about it to reduce it. The second thing we can look at, to improve scalability is, how do we deal with flooding? So if we improve that, then we improve, our scaling, capabilities here. So one way is to actually, work upon new flooding topologies. Another way is actually, really look into how flooding itself is done. And then the third thing, what we can actually look at is like, is how SPF is done. Right now we have Dijkstra. Dijkstra is, quite okay. It's not too complex. And it's probably the best we can do without creating too much additional complexity. So if you look into the middle point here, so what are the different scaling limitations here? So looking into it from a historical perspective, so something what we have is our packet pacing and the throughput itself. So initially when ISDS was created, between two control plane packets, there must be about 30 milliseconds. And the reason is because, in the older implementations, if you would send too much packets at once, it may actually overload your neighbor and you actually may lose packets and, all bad things kind of happen. Now, with those 30 milliseconds, it also means that if you have like a really big network, let's say about like 1,000 nodes, that actually has like quite an impact, because 1,000 nodes will result in approximately, for a full sync going from 0 to everything in about like 30 seconds, because we have these 30 milliseconds packets between the LSPs. That's a lot of time. We can do much faster than that, because why do we have those 30 milliseconds? It's because of the older implementations of ISDS and the way it was done. So the other element here is like the reliable flooding on point-to-point interfaces. So
each, LSP needs to be acted on a point-to-point. So that actually comes with like, packing the packet itself and some associated timers, with it. And then the third element here is like, okay, the unreliability of the complete sequence number of packets. So if you're on a point-to-point interface and you come up, with the two routers, they each exchange, their link state databases using CSNMPs. In each CSNMP, we can stuff in like about like 91, different, LSP descriptors. If you would lose one, it actually automatically, multiplies itself by, 91 LSPs being exchanged between each other. That's quite significant. So, and that is actually why we say, okay, why not do this exchange instead of like let ISS take care of it, set up a TCP session and actually, push all of the LSPs into that one. Now, of course, if you want to set up a TCP session, you need to know the IP addresses to be used, v4 to v6, and you need to know the port numbers on which each of the routers actually is, listening. So that is something you can actually signal between each other by, creating or adding like a new TLV in the ISH, in which actually have like different, TLVs, sub TLVs itself for the port number, the v4 address or addresses, and the v6 address or addresses. And right now, at this point in time, we think that is sufficient at this moment. And again, also because TCP uses a byte stream, and because we like BGP, we're going to put like a marker in there, which we have preset in our draft. So the new behavior itself is to actually establish the flooding. So in essence, when the link actually comes up, they actually exchange ISHs, and each router will sort of like look for this new TLV to figure out the IP addresses, what is used to also figure out the TCP port number. The router with the lowest router ID will actually initiate TCP session and set it up. So from the moment the TCP session is set up, you actually will exchange only one time an ISH over the TCP session itself to make sure that the guy you see on the other side is actually the guy you think he is. And so you can authenticate and make sure about that. So only one time you will send, the ISH about it. For the rest, on the normal link between the two routers, not over TCP. So the neighborship establishment is still being done by exchanging ISH messages on the link itself. So nothing really, changes from that perspective. So it all stays the same, which is very good because if you have like a control plane failover on one of the ends, you don't want that the TCP session itself creates additional, dynamics and, neighborship complexity, from where we are. That is all, described pretty well, in our draft. So the nice thing is, when you do this, now what will you win? So in essence, what you win is what you see here on the bottom. It's like no more retransmissions of LSPs or verifications, using sequence number packets, because everything now is in the hands of TCP. And that is really nice. You don't have those 30 milliseconds anymore. You can actually send as quickly as possible, as fast as your neighbor actually can accept. And TCP will take care of the windowing and about, everything else. And then of course, we also have like, new behavior, like, during, during the flooding itself. So a few small things actually changed, but in essence, nothing really, super dramatic. So if you receive an LSP, and it's the same version, the router really doesn't do anything at all. If you actually receive an older version of an LSP, then basically what you do is like the send routing message bit itself, and you return like a newer LSP towards the peer. If you receive like a newer LSP, then you actually, use it and you flood it to, to everywhere else. Yes.
This was for the end of presentation from the Java room, so I can wait.
Yeah, we're also really getting out of time.
Yeah.
We got 2 more presentations to do in 10 minutes.
Yeah, let's take this to the list, the discussion of this one.
Okay.
Okay, yeah, but I'm kind of finished, so we actually have some additional thoughts and considerations. So, but in the interest of time, I'm gonna skip them. The only thing what I want is, and I think the draft right now is in a reasonable shape, and it would be nice to see, if it can be actually, adopted to the working group, yes or no.
It just came out.
I know, but
why don't you start a discussion on the mailing list?
It's a good draft.
If we have, we're going to take the next slot.
How many people read it?
I read it.
At the next
but a lot of
slot,
people read it.
in the next slot, if we have time, we can come back and have a discussion.
There's one thing that I have to say, I'm going to check into it more. There is a Cisco provisional patent that has TCP flooding of the IGPs as a component of it. I'm not sure. I'm going to check with our legal to see if it's applicable or not. It doesn't go into this level of detail, but I'll check on that. Okay, Kenton, can you do 2 minutes?
Can we get the presentation up in that fast?
I'll leave it to you. Unless you want to see a grow presentation, I'll leave it to you. It's just SRV6.
Okay. Yeah, I think 2 minutes should be good for this.
Okay.
Ketan Tahalikar, Cisco. So this draft has been out there and presented a number of times. It's more or less stable at this point, and just a couple of changes which were added in the recent update for more clarification. One of it was clarifying that the SR algorithm TLV, which was there in the ISIS extensions for SR and PLS, are also applicable here at SRv6. And there were some function behavior points .dx and DT6 which were included in the draft, but there was no use case or documentation for what they are used for. And so we have removed that in this version. So really that's the only change. The next step, there are implementations of this draft already out there, and we'd like to ask for working group adoption at this point.
How many have read it? Okay, not too many. Should we start a discussion if it's ready for adoption or adoption?
I think we could just do the
Adoption,
adoption
yeah.
and if people can object. Okay.
Right.
Okay.
Okay.
Thanks.
Thanks. Great.
Every time it jerks like that, I'm scared it's going back to grow.
Yeah, that was bizarre. Apologize for this. What I figured out is we were using the agenda and not meeting materials, and anything that wasn't in PDF format wasn't on the agenda. So we had to go to meeting materials to get all the PowerPoint presentations. Dan?
Yes. Hi. Chinwoo was supposed to give this presentation, but due to NetMod clash, I'm standing in for him. In the interest of time, I'll try to make this as quickly as possible. Next slide, please.
This works actually.
Yeah, but it's a
I have
PDF.
technology. Okay, good. So this is it's an ID to basically provide discovery of secure PCEs capable of supporting things like TCP/AO, TLS, TCP MD5, so that the path computation client, PCC, can send and receive information related to path computations securely. It's a very simple document. Essentially, we have one sub TLV with 3 options. There they are. Specifically advertising what type of security the PCE will support. So essentially, this is just a sub TLV for the IGP, and we would like the working group to look at the document. It's a relatively recent document. I think we published it probably about 6 weeks ago. I think AC's already made a comment that if we use TCP/AO, we will have to provide some shared secret information. That's not currently in the document. There are some potential security risks with that we need to discuss, or at least identify and disclose in the document. And yeah, I think that's it really.
Yeah, we were just gonna. I think what we talked about was just using like an SAID. We're not talking about putting any keys in there. This is coming from, PCE uses the IGPs as a tool. This has both ISIS and OSPF. And they are coming and saying that this is a good thing to do. I can't see any reason why we wouldn't adopt it, speaking as chair.
Yeah, I mean, there's some
Call for adoption.
so there's some precedents here as well, because there are sort of numerous PCE capabilities that are advertised through the IGP.
Yeah. Go ahead. Okay. Back when the PCE working group first established, they came first OSPF and then ISIS, and we have the drafts that are referenced in this document. refer to that, and then they're just extending more bits, and then we'll have this key ID for TCP/AO as well. So, okay, go ahead.
Well, I was just going to say, if there's no more comments on this, there were two people that wanted to talk about TCP.
Oh yeah.
So
Tony
we do
and,
have 5 minutes.
Yeah, Tony and.
If you guys want to bring your comments about the TCP.
Tony Lee, still at Arista. So I'd like to say that I support this work. I think it's very good, and I think we should consider using QUIC instead of TCP. This is because slow start actually is going to be a factor. And I apologize because I jumped on your comment taking it to the list, so I already sent it to the list.
Okay, well, that's good. Mika, did you have something from Jabber on the TCP?
But if you said that it should take it to the list, that's what I told you.
Okay.
Okay, through dictatorial edict, we finished on time. And we're going to be back here at 20, to start promptly at 20 after.
Yeah, on the dot.
On the dot.
11:20.
I think, looking at the presentations, I don't think we should be as rushed as we were during the first 2 hours. Okay.
See you back here.
Yep. Me too. I hope that nobody grabs me. Actually, I'll take my phone back.